But this makes also that we have much bigger volume of data. We have to treat a huge volume of data, which posed the question of the integration, and we spoke about this question in the last webinar. Now, to make all this efficient, technology is very good. We all know that it's required, but technology is not enough to run properly these smart buildings. So this requires smarter organization. It requires smarter processes, and requires also smarter people. Imad Al-Habti will be presenting this management of the whole life cycle for the buildings and property, and will speak about the integration of technologies in this management.
Good morning, everyone. Happy to be here and talking you through the way we should be able to use technology to track whole life cycle costs for assets and by large systems. To start with, I would like to basically, sorry. Sorry, as a matter of introduction, I would like to take you through what the built environment represents in terms of wealth across the world. I'm not sure if you... Okay. Yeah. So a large part of the world wealth actually ties up in physical assets. As this chart shows, I mean, we have these 30 countries makes up 80% of the built environment across the world, and as you can see, the built asset is actually 3 times the GDP produced by these 30 countries. So that gives you an idea on how important it is to look after these assets in terms of managing them across their life cycles. What's the definition of whole life cycle? So basically, according to ISO 15686, it's basically the economic assessment considering all agreed, projected, significant and relevant cost flows over a period of analysis expressed in monetary values. So what this says basically, it brings a level playground in terms of discussing monies rather than type of maintenance. So we're talking here about what the cost is in terms of projected cash flows over a period of time. These projected cash flows are needed so that we can make informed choices in terms of selecting assets, as we will talk about that in a few slides. Simplified definition goes about mentioning the fact that we systematically consider all relevant costs and revenues associated with the ownership of an asset, from its inception to the time we dispose of it. So what do we expect from deploying tools to measure whole life cycle costing for assets and systems? Well, as I said earlier, it will help us make informed choices. If you're confronted to 2 choices, one way of picking your selection is basically by looking at the projected costs and revenues across throughout the life of the assets and basically making a choice. So practically, if you have to pick between, let's say, chillers, what type of cooling means you will pick from water-cooled chillers versus air-cooled chillers versus district cooling chillers. One way of making your choices is through estimating the whole life cycle cost of the 3 solutions and then picking up the one that's the cheapest actually. We are also pushed to use this technique when we are basically confronted to alternative specifications. So again, we look not just the capex as the acquisition cost, but we look at the whole life cycle costs. It also helps people do an in-depth analysis of their business needs. So before embarking in expensing a lot of, large sums of monies to acquire assets, it's really always useful to look at what the running cost will be, rather than restricting ourselves to just the original acquisition costs. Because we will be, as we are measuring assets cost, measuring life cycle costs, pushes us to basically look at what is it that we would like to achieve from acquiring these assets. What is it that we would like to achieve in terms of maintenance? What the uptime we're looking for? What are the costs we're ready to expense? What we're ready to basically pay to make sure that we can cover for maintenance of these costs. So that sort of analysis is always useful to project owners and asset owners. Well, These costs are mainly made of, as you could imagine, acquisition costs, which are the supply and installation of these equipment. Then we have the MRO costs, which are basically the maintenance, repair, and overhauling of assets. And these are basically twofold. First one is the man hours we have to spend maintaining and looking after these assets. And the other part is, of course, spare parts and consumables we have to pay for, to look after the assets. And a large component in terms of cost will be the utility costs. That's basically the case for large assets such as chillers, for example. And finally, at the end of the life of the asset's life, then you have the disposal cost. It's important to note that we could add additional costs to these, such as, for example, the environmental costs. If you are, for example, to consider the utilities used to power up these assets and then their impact in terms of greenhouse gases, that's something we could and actually should consider in our costing of whole life cycle costing of whole life asset costs. So as mentioned earlier, there should be a time profile from when the cost occurs or reoccurs. This time profile will always generate a series of cost and time repairs. And of course, cost can differ from one time to another, and they should, as it is the case in real life. So to make these exercises of obtaining life cycle costs meaningful, these costs have to be as accurate as possible. This is actually the catch. It's really difficult to make sure that these costs are actually basically accurate, because you're projecting forthcoming costs rather than past costs. So there are ways of making sure that these costs are as accurate as possible. So first one is to go with direct measurement. That's by far the best way of measuring these costs. And as I was saying, so the CAFM will prove itself to be a useful tool with this regard. And the second part will be to looking at historical data and direct estimation from typical applications. That can be useful in absence of direct measurement, but direct measurement is actually the way forward. Then if in case of data isn't available in the public domains, or access to it is being restricted, or if these data are not relevant to the country we're operating in, then basically model based on expected performance can also be used. And finally, best guesses can also be used if we are foreseeing a trend in technology change that's about to happen. So as I was mentioning, direct measurement is by far the better tool. The problem with that is measuring, getting accurate estimation of cost comes always as a cost, basically. So, for example, meters are required if you are to measure energy accurately. You'll have to install meters. You can't do without that. In practice, there will be a mix of the four ways of measuring costs across the portfolio of assets an asset owner will have, and measuring them specifically through meters and through the CAFM, as we'll see later, should be the way forward for large and energy consuming assets, while the other three ways of measurement of whole life cycle costs can be used for the less important between brackets assets. Of course, if you're talking about whole life cycle costs, you're talking about discount rates, so that also have to be looked at carefully. It will have a huge impact in terms of estimating, in terms of basically calculating future costs and putting them in today's values. So weighted average cost of capital can be used by corporation to as a discount rate for their estimations. The period of study is also important, so that's either the foreseeable ownership life or ownership of the assets, or the assets life as basically foreseen by the manufacturers. And finally, the format in which these whole life cycle costs should be presented is also of great importance. So basically, most of the time we'll have to resort to NPVs, which is basically just a number telling you what will be the cost in today's value, in today's money, of the future cost expenses, be it for acquisition, be it for maintenance, repair, and overhauling, or be it for energy. And of course, a lot of hypotheses have to be used to estimate, for example, the variation of energy costs in the future. What we did here is basically that's the first example of whole life cycle costing. And in this particular example, we took a bump. So we've assumed what the acquisition costs were, and we've assumed that the life cycle of this pump, so the lifespan of this pump will be 16 years. And then based on the OEM's data, we have estimated the MRO cost, maintenance, repair, and overhauling costs. And as you can see, there are spikes of cost around year 5 and year 10 and further. And these costs here are displayed without being discounted. So the last column actually is showing you the sum of these costs with a discount using a discount rate of 9.2%. So we're assuming that this corporation has a WACC of 9.2%. So the NPV value turns out to be 795,000. So that's basically the whole cost of maintenance, acquisition, and energy that these assets will be costing the corporation that decided to install it. Example 2 shows how we should go about picking options from, for example, we're confronted to a choice. We have product 1, which has these discounted costs. So in this particular case, we use water-cooled chillers, and product 2, which is again a water-cooled chillers, but from a different manufacturer. And again, based on data from OEMs, we have estimated discounted cost, i.e., expressed in today's money, of what is likely the cost of these products throughout their life. So the table on the left-hand side shows you basically what were the acquisition costs. So initially, product 1 costed 4 million roughly, and product 2 3.3. But the NPV shows a lower NPV for product 1, 35 million versus 27 million for product 2. So if we were to make a choice purely based on the initial cost, we'll have gone with product 2. But actually, product 2 has a higher NPV. That's mainly due, in this particular case, because these are chillers, mainly due to the energy consumption of the machines. So again, a better COP for product 2 has basically yielded a lower NPV. Sorry, better COP for product 1 has yielded a better NPV, but that could not have been foreseen without looking at these projected costs. So that's one way of using whole life cycle costing for assets before making informed choices. So as I mentioned earlier, we said that these costs, which are basically the acquisition cost, the MRO, the utility, and disposal costs, have to be estimated. The best way of going about estimating them is using actual measures. Unfortunately, that's not always possible, but sometimes it is possible. So the second part of this presentation is about how the CAFM systems can be used to actually provide you with a means of measuring and capturing these costs. So again, for now, given the complexity of these assets and complexity of FM operations for any building, regardless of its size, it's almost impossible to run these operations without a CAFM system. But what I want to insist on is not just about what CAFM you're going to pick. It's also about what business workflows you're going to deploy onto this CAFM. I mean, CAFMs right now, technology in the markets, you have a lot of CAFM that pretty much do a lot of similar things. But what's really now being overlooked a lot is what do we want the CAFM to do? How do we want to roll out our business workflows? How do we make sure that we capture these costs? So that's the most important part of what will follow. Sorry. So I didn't mention workflows. So basically, these workflows have to be robust, and the CAFM has to be able to basically roll them out. So any CAFM, an FM company, or an asset owner will have the facility to build, will have an engine to build these workflows. And in terms of processes, to be able to basically track costs and attach them to assets, there are some criteria that have to be met. There are some obligations that these business workflows have to fulfill. So we're listing a few of them here. So first of all, no activity should take place in any sites or for any assets without a job ticket being created for it. That's a must. And then these job tickets, these workflows should mandate the need for one job for a job ticket to be attached to assets, and actually not to more than one asset. So that's a must again. So by doing that, we're capturing the time used by technician on executing the task as listed in this job ticket to the particular asset for which the job ticket was raised. So that's important. Similarly, on spare parts and consumables, again, they cannot be just basically acquired be it from the stores or be it from through a third-party supplier, if they are not allotted to specific job tickets. Again, it's just common sense, but it really matters. If we don't do that, it will be very difficult to basically allocate costs to specific assets, and hence you won't be able to work out the whole life cycle costs. So, and finally, in terms of manpower, again, technicians and operators, building operators, have to be assigned to job tickets. Again, just common sense, but it makes everyone's life much more easier, and it makes this process of gathering information on assets far more smoother. Then, other aspects that have to be taken into consideration is the fact that these CAFM have to be populated with asset registers. Again, most of the CAFM nowadays do that pretty easily. But what's really lacking in the market right now is disciplined teams. Teams have to be disciplined enough to say, okay, if I am spending so and so man hours working on that particular asset, I need to make sure that the way I document this, the CAFM system really reflects that. If I work on pump 1 and I spend my time working on it, I should make sure that the CAFM is documented accordingly. I should not allocate these man hours to pump 2 for sake. Discipline is really key. If you do that, then basically it becomes quite easy to track what we call ongoing costs. So there's a slight difference between ongoing costs and life cycle costs. Ongoing costs is the costs that have been expensed so far from the beginning of the asset till today. Whole life cycle costs look at the past as well as the forthcoming costs. So the key message here is disciplined, focused, well-trained teams are essential to gathering the actual ongoing costs. And as energy becomes more and more expensive, and this trend is to continue over the coming years, so it is basically common sense to note that energy consumption will make up a big chunk of the cost throughout the asset's life. So again, how do we go about recording them? Then we have to have meters. There are no options about that. Now, do we go and install meters across every kit of equipment? Yes, if you have depot beds. That's not very realistic, however. So, but energy consuming assets will have to have permanently fitted meters. That's a must. We can't do without that. And then portable energy meters, good ones, not stuff that we found fortunately in the market. Good ones should be used to measure across a period of time consumption, utility consumption for typical assets. These readings can then be used for other assets provided that the pattern of use is carefully considered. So, and then the question is, how does the CAFM can help with regard to energy costing? So you can actually record these readings either manually or through an integration between server to server, so integration between the CAFM server and the utility metering servers. That's something that can be done very easily with the existing CAFM. That's not something that requires any customization or new development. So basically, you create a meter, you attach them to assets, and whenever meter reading is due, then basically the system will generate a work order or a job ticket asking you to go and take the reading. And again, we go back to discipline, and we ask technician to actually record the reading on the set times, and then basically you start building up a large array of information. So these ongoing costs are measured, of course, since the installation of the assets, provided that your CAFM is geared toward doing that your business workflows are in place. And within a certain period of time, you'll have a wealth of data that's basically quite revealing with regard to how the facilities and how the assets are being looked after. So just listing here an example. If you have a set of FCUs of the same brand, of the same capacities, and installed in similar, let's say, corridors, and you come to notice that basically ongoing costs for one FCU are higher than the others, then basically this should trigger some investigation. Again, you can ensure that your CAFM tools are geared toward giving you these kind of reports. So basically, you spend less time looking for information, and you have plenty of time analyzing it. So that's the added value of well-rounded the CAFM system can do to your facilities. In terms of analysis, so basically what I was saying is you have to, based on the past costs, which are what we call the ongoing costs, you can make up realistic hypothesis of estimating the forthcoming costs. So now we're back to estimating whole life cycle costing. As we said earlier, we said that basically people tend to use OEM's information, to use data that's on the public domain, but that's not enough for you to do, to actually assess realistically what should be the whole life cycle cost of any asset. But if you do collect a large array of information on the ongoing assets, then basically you're down to making realistic hypothesis for estimating the forthcoming cost. Either you estimate that there will be a change in patterns, pattern change in the way maintenance is being conducted. You can actually run, not simulation, but you can take the same assets and put some of them on CBM, condition-based maintenance, and keep the other ones on PPM, and you get to see what will be the impact on the assets, as well as what will be the impact on cost. So that information you're collecting through your CAFM is a wealth of information and should be put to use. So the benefits, again, we're back to benefits. So we're talking here about promoting realistic budgeting for operation and maintenance. So you need to work out the budget for operating a shop remote, for example. Because you have ongoing costs, it's easier for you to make a budget for coming years. You still need to look at OEM manufacturer documentation with regard to overhauling and stuff like that. But you're actually having data that's basically that nobody can challenge. It also pushes discussion among the teams. So, if a pump has been installed in project A and has proven to have high ongoing costs, so it's key that this type of pump is not to be used in project B. So again, we're talking here about benchmarks. We're also talking about basically if you are to make informed choices, you have data that's valuable. I remember in one of the projects we were involved in, there was a discussion about what kind of power allocation should be given to FNB unit, food and beverage unit, and the CFC called for 1,000 watt per square meter, and we actually that project was in Bahrain, and there were limitations in terms of power. So we were asked to look at what were the actual power consumption of similar FNBs in running projects, and we came back and we said, look, 1,000 is a bit an overkill, and we can do with less than that. And so you do that for a lot of assets, and basically you can save immediate costs. I mean, in terms of transformers, in terms of connected load and stuff like that. And again, you have much more chances convincing your asset owner if you have collected this data over the past years. And here again, it's the same stuff. So it's about supporting decision making. So it's not anymore. We're not again relying on databases that may not be relevant to the country you're in. You still need, however, to make some judgment calls. So you still have to decide of what is it that we need to do with regard. So these are the past costs. So how do we go from here to projecting the forthcoming costs? So judgment calls are still needed, but they become a bit more easier because you have collected data over a few years rather than just a few months. And finally, it pushes operators to look at how their maintenance is impacting the assets, how these assets are well looked after. For example, if you have the sudden change in year-on-year ongoing cost, then this should immediately trigger a discussion. So has the cost increased because rates have increased, utility rates or manpower rate, or is it just because the manpower actually have been increased and we have faced basically downtimes? And in that case, the maintenance regimes should be reconsidered and looked at. And that's it. Thank you very much for listening.
Thank you very much. We'll now open the webinar for any questions. So we can see here the questions that you want to send through, and we'll do our very best to answer those, so any that are coming through. But yeah, thank you very much. That was really interesting. I don't know internally if you've got any questions at all.
This is just generally, Gary, right? This is really about having the information, isn't it?
Yes.
So to make future decisions. You're working though often from a low base. You have no information at all. So as soon as you install that system, what are the immediate benefits? Say within a year.
Well, it's better budgeting. So basically, you will be able to make informed choices. You'll be able to communicate with your client and tell them, okay, these are real costs. We're measuring them, and nobody can come and debate them. And then from there, you build up on investment plans and say, okay, I have a chiller that costs me so and so in terms of whole life cycle cost, and it's there for the next 15 years. And I have this other solution that basically will yield a lower life cycle cost. So it's better for you as an asset owner to decide to basically replace them. So information is key, definitely, yes.
Are you able to share that information for a particular piece of kit in one building? You can use that information, or can you provide that information for people to use as a comparison elsewhere?
Yeah,
you can do that, and that goes on.
Yeah, because I mean, you get to basically know how assets are performing down to the brand if you wish so, and then from there you can, if project A is running on sort of equipment and project B is under development, and of course you should, that's really key, translate this information and pass it on to the developers of building B.
You also said about the meters being fitted to individual units.
Yeah.
How many do you need to do? You really can use one as an example and use that for a dozen, or do you would obviously recommend people meter everything if they possibly can and they can afford it?
I know that's not very realistic, but assets that are energy consuming, the likes of the chillers, cooling towers, the pumping systems, these are key assets, and you don't have a lot of them in buildings. Cost of meters are now coming down. They are more accurate, more efficient, and basically they can sit also on their own network. So basically collecting information becomes very easy. So these meters have to be installed. You can't do without them.
I understand. We've got some questions coming in. The first one, and I suspect this is going to be a repeat question, what CAFM system do you recommend to manage this process?
Well, as I said earlier, it's not so much about the CAFM you're using, it's about what they make of it. There are a lot of FM companies in the marketplace that actually you keep hearing information about them shifting from one CAFM to the other. It's not so sure it's the issue is the CAFM itself or the business workflows that are out through it. So CAFMs right now, and there are a lot of them, I'm pretty sure sellers will be happy to come in the presentation. But it's for the users of these CAFMs to sit down and write down the business process they would like to roll them across these CAFMs.
So it's telling people it's not really about the best system, it's about this is what I want.
Yeah, it's a solution, actually. It's a combination between the CAFM, which is basically the software, and the business workflows, which are inherent to your business.
Talking about the CAFM, I think what was important in what Imad says is not only about what CAFM system you buy, it's what are the processes, and what you have seen here. Most of the companies, when they talk about CAFM, they talk about PPMs, about planned preventive maintenance. In the last seminar, James talked about condition-based maintenance and other type of maintenance that we integrated. And the new thing here also in Imad's presentation, it's about operations maintenance, capturing the data of the operations metering, putting this in a database, and then be able to analyze these data and link it between them to take decisions for the whole life cycle of the building. So it's not about what CAFM system to use, it's what you want from your CAFM, set up the right processes, and most of the CAFM system now, the new ones, when they have proper workflow engines, they are able to manage these requirements.
Good. There's another question which I'll add to. How do you ensure processes are followed so that the information is fed into the system so that required MI is collated? I think one of the key things must be is the discipline of the people around you. You said about job orders being, for everything that gets done, it has to be recorded and done properly. That seems to be a key to this.
It is. I mean, again, it's information, so you want to make this information as flawless as possible, and hence you'll have to push your guys to basically abide by the processes. The process says no work is to be executed without a work order in the system, then they have to do that. Now, you can still mandate that, and they can go around it and do something else, but that's the job of the manager to make sure that, through audits or inspection, to make sure that these rules are being abided by. That's definitely important, yes.
Is that one of the main difficulties at the moment, that idea where the system may be in place? If that is not just the key, that's the foundation of this. If that isn't done, then the information becomes useless.
It is, and one way of pushing that agenda down the road is basically by also highlighting the fact that, I mean, the market right now, you have owners that are, when they have offers from FM companies, they tend, unfortunately, to look at the commercial part and overlook the technical part. So that's important. And by just trying to push costs down, and basically you're not sending the right message across to your partner, assuming the service provider is your partner. So that's not good enough. So basically, if we want self-motivated technicians and operators, disciplined ones, then basically we have to reward them accordingly, and hence it's not just about the cost. So asset owners have to play the game and basically say, okay, what's in there for me in terms of that those guys will be looking well after my assets or not. Once we have this, once the clients get past that, then basically it's going to be very easy to get good technicians, train them well, and basically reward them well, and that's going to happen. What we're talking about here will happen definitely.
And that's a big part of getting things used to.
Definitely it is, yes.
I understand. Another question, this is another thing about making the job easier for people. Can you mention examples of brands of tested portable energy meters? Again, people are asking about brands. I assume the answer is going to be...
Look, I don't want to mention names. I mean, for obvious reason. I can share with you. I don't want to go by names. I go by specifications. So basically, specification of the meter. We're talking about accuracy. We're talking about the predictability of measurements, rather than names. But the good ones are quite known in the market. I don't want to mention names.
Okay. Let's see what else we've got. People are talking about energy conservation. I know you touched on this just briefly. This is Salman Sharif. I would like to know more about energy conservation in CAFM. How can we achieve it? And what are the functions and factors affecting it?
Yeah, I did briefly mention that. You can, with the new CAFMs, you can actually create what they call meters. So a meter is not, as it sounds, a physical meter. It can be anything. So it can be, for example, an hour meter that tells you once the pump has run, let's say, a few hundred hours, that it's due for maintenance. Sure. Or it can literally mean an actual electric meters. So basically, if the meters are just normal meters, i.e. they require manual recording of data, then the work order, you create the meter in your system as an asset, and the system itself starts generating work orders automatically based on set frequency, let's say once a month. And that meter, that work order, again, we're talking about disciplines and workflow, will have to land in the technician, handheld device, for example. He goes around and takes the reading, and that reading then is uploaded and exists on the system. And you can call on it, download it from your CAFM whenever you want.
Good. And that, from that point of view of energy conservation, this can be a selling point for you to actually go to people.
I mean, you can't save energy without starting by measuring it, so that's the starting point, yes, definitely.
Good. I have a question here. How can you project energy costs over the lifespan of a building when energy prices fluctuate globally?
Yeah, that's what I was saying. I mean, in terms of, if you have past information on kilowatt hours, let's say, so unless the pattern of use of this asset is about to change, the kilowatt hour will remain the same. Might go up and down might go up slightly because of normal wear and tear of the equipment as it ages. Now, making informed decision on what the rate of utility is likely to be. I mean, there are lots of papers around the world telling you what these costs are likely to be. If you look, for example, at DEWA, I mean, the last time I think DEWA has increased its rates, it's been more than 8 years. It doesn't mean that the cost won't jump quite drastically over the coming years. These costs are and will go higher and higher. I mean, this part of the world is moving away from subsidizing rates, but you will have to make basically informed choices as much as you can.
This again touches on the sustainability. How do you see CAFM systems monitoring, reporting on ETA and LEED certification, this idea that buildings are built to a standard?
Yeah, I mean...
Does CAFM work well with that?
Again, the CAFM is just basically the software, so whatever you get in, you'll be able to put it out. Now, when it comes to ETA, I mean, the part about metering that falls under ETA, yes, definitely, as we said, that can be tracked through the CAFM. Other aspect of ETA, that definitely cannot. I mean, if you're asking about, I don't know, how many, the way you should design your roofs, that's not something that CAFM can track for you. But again, that's my personal opinion. What's really important is about talking cost.
Sure.
So as far as you can measure it, you can put this information back into the CAFM. There's no question about that, yes.
And you decide what you need to know.
Exactly.
There's a good question there. How can you practically measure and implement whole life costings of an asset if the equipment and machines used by the facility is old, say working for more than 20 years already? Now I assume if you went in new, you would take it as day one. Okay, the building's 20 years old, but this is where we are now.
Yeah, I mean, yeah. So basically, you look at it from the starting point. So you're now, the equipment has 20 years, has been running for 20 years. So of course, its life has been shortened. So we're not talking about the cost of overhauling is likely to be very high. The regime of maintenance that have been used in the past have to be looked at. You could make a judgment call, but it's, I mean, definitely, I mean, it's not whole life cycle costs are not for off-the-shelf new assets. You can do them at any period of time for assets, provided you have cost information, because that has an impact on the likelihood that the assets will last for a few more years. Basically.
Question there from Amit Wakley. Today, everyone is now talking about building information modelling. New BIM would come up. With the Dubai government making it compulsory for all high-rise buildings, how does BIM help in managing energy when comparing with CAFM or even BMS?
Well, we're talking two different things here. BIM is not competing with, BIM is not an energy management system, and BIM is definitely not a CAFM. So BIM is basically, well, it makes, I mean, according to whoever promotes BIM, it makes the designer's life much more easier, the transition between construction to operation much more smoother. You have a huge number of data that you can make good use of. That's definitely something that building operators will be keen to use.
That idea that you can see how the building was built and you can follow it through. And
during construction, with BIM, you have managed to avoid clashes between MEP lines and stuff like that. That's great. Now, how does it make an impact on energy? Not really. I mean, again, energy is about selecting the right products, mainly through looking at whole life cycle cost. You take a building, for example, you have a facade glazing of a certain U value, and if you decide basically to change the U value and go for lower U values, basically that will end up having a huge impact on your chill water system in terms of reducing it. So these are value engineering exercises through which you can use the whole life cycle cost to estimate costs. BIM isn't something, I mean, BIM can, again, you can input this information, value engineering information into the design and see what the impact would be quite easily with BIM in terms of size of the ducts and stuff like that. But not so much in terms of energy.
Okay, I understand. There's a question there that I'm not sure. Just a second. It was the one about somebody was asking whether you had to do the whole system. I think it was that idea where you could maybe pick and choose within the CAFM system what you monitored. I assume that could be done as well. You don't have to do everything.
No, you don't.
You could select. I just want to look at.
Yeah, I mean the big ticket items will have to have meters. Yes. For the rest, no. But you still can choose to use the CAFM to record this information. Nobody stops you from using the Excel sheet to do that, but it's far better to do that on a CAFM system.
Good. There's Hayan Sayed there. What equipment is needed at sites to track and record info for WLC analysis? Can we interact, guide the end user to better operate an asset?
Can we interact, guide? Yeah.
Does that make sense?
I mean, as we said, I mean, whole life cycle cost, the CAFM helps measuring ongoing costs. Yes. So these are maintenance costs, and CAFM is good at that. That's what CAFM is for. Energy costs, and we saw how we can use the CAFM to track these costs. So definitely, it's a matter of business workflows, discipline of teams, and you can do that with your CAFM. Now, going from these ongoing costs into whole life cycle costs requires assumptions. Again, the past course will give you leads in terms of what assumption you should be taking over the forthcoming, over projecting the forthcoming streams of costs attached to these assets. That can be done on basically download information from your CAFM and work it out. And you can do that on Excel sheets or use WLCC's models.
What I would say at this stage, obviously there are a number of questions here. I know that afterwards, any questions that we've not answered, you'd be happy to look at those. So if people want to continue sending in questions for the next
of course we can.
20 minutes, we'll certainly look at that.
Yeah, happy to listen to them.
And in addition, I know that you will be available next week at FM EXPO.
Yes.
I think we mentioned this, so anybody who's here, if they're coming along to FM EXPO next week, which is,
to approach us,
they can come and see you. So that's from Monday the 18th to the 20th, FM EXPO 2015 at the World Trade Center. And your stand number, Doctor, I believe you know the stand number. I've not got it written down here.
I think it's B191.
B191.
B191, yeah.
So if people come and find you on your stand, you're happy to talk about this and give more time to people.
with pleasure. Definitely, it may be sometimes frustrating when we do webinars. We can't answer to all questions.
Sure.
We have a lot of questions. So definitely, Mad, like James last week, will be more than happy to answer to the question that you may receive. But I invite all of you to visit us on our stand in FM EXPO, as I said, B191, and we'll be more than happy to answer to your question and to exchange with you.
Excellent. I think that's it. I'd like to thank you both very much for coming this morning.
Thank you very much.
Dr. Hayan Sayed and Ahmed